In this PowerPoint, we're going to examine tectonic forces and look at how it continually reshapes the Earth's surface. The theory of plate tectonics explains how forces within the planet create landforms. This theory views the Earth's crust as divided into more than a dozen rigid, slow-moving plates. The plates can be compared to the cracked shell of a hard-boiled egg. This diagram illustrates the plates that compose the Earth's surface. The plates slowly move across the upper mantle, usually less than an inch per year. This process is called continental drift. As the plates move in diverse directions, a variety of landforms are created. These arrows indicate which direction the plates are moving. In the next few slides, we're going to examine what kinds of features can be found at these different types of plate boundaries. Volcanoes often form long rows and signal that a plate boundary is nearby. Earthquakes, sudden shakings of the Earth's crust, take place when tectonic forces cause masses of rock inside the crust to break. Earthquakes are also common near plate boundaries. The Ring of Fire, which you see here, is a perfect example of volcanoes and earthquakes that form along plate boundaries. The Ring of Fire is a location along the Pacific Ocean where most of the world's active volcanoes are found. These volcanoes are formed as the Pacific Plate is being driven under continental plates, forming subduction zones. We're going to be looking at three types of boundaries: convergent, transform, and divergent. The first, convergent boundaries, these are formed when plates collide. Which type of plates that are colliding dictates the landforms that will result. For example, when two plates on the ocean floor collide, one slides underneath the other. This plate boundary is called a subduction zone, and the deep valley marking the plate collision is called a trench. The plate sliding downward generates heat as it grinds against the plate above it. This may produce a row of volcanoes. Some of these volcanoes rise as high enough to become island chains. Sometimes one of the colliding plates is carrying a continent. In this case, the heavier oceanic plate dives under the lighter continental plate. The squeezing of the continental plate causes volcanoes, folds, and faults. It's also possible for two continental plates to collide. The result is a great long-lasting episode of mountain building with awesome folding, faulting, and volcanism. The Himalayas of Asia formed along such a plate boundary. This diagram represents two continental plates colliding and demonstrates what we find in Asia with the formation of the Himalaya mountains as mentioned in the previous slide. As these plates continue to drive together, the Earth's surface is thrusted upward, resulting in the formation of mountains. Using this slide and some of the things that we've already discussed, complete the convergent boundary section of your graphic organizer. This diagram on subduction zones shows what happens when an oceanic plate collides with a continental plate. A trench results as the oceanic plate is driven under the continental plate. This pressure results in mountain building and the formation of volcanoes. The Andes Mountains in South America is a prime example. Next, we're going to examine transform boundaries. Although most of these plate boundaries lie under the ocean, there are a few examples we can find on land. Transform boundaries are formed when plates are moving alongside one another in opposite directions, as shown on the diagram. Although earthquakes can occur at all plate boundaries, they are usually associated with this type of boundary. Faults result along these boundaries, and a prime example is the San Andreas Fault in California, where seismic activity is very common. Complete the graphic organizer section for lateral or transform boundaries now. The third type of boundary is formed when plates are moving away from each other in opposite directions. These are called divergent boundaries. Two examples include the Mid-Atlantic Ridge and the Great Rift Valley.